Unlike the other planets in the solar system, Uranus is tilted so far that it essentially orbits the Sun on its side. How did Uranus end up on its side? Uranus is arguably the most mysterious planet in the solar system. We know very little about it. So far, we have only visited the planet once, with the Voyager 2 spacecraft back in 1986. The most obvious odd thing about this ice giant is the fact that it is spinning on its side. With its poles almost in the plane of the solar system, almost like a barrel rolling around the Sun, rather than spinning like a top, as the other planets do. Uranus has the largest tilt of any planet in our solar system, and it spins on its side. This means that one of Uranus' poles is often pointed towards the Sun, giving Uranus very long seasons. The axis of rotation is approximately parallel to the plane of the solar system, with a tilt of 97.77 degrees. This feature gives Uranus completely different seasonal changes, unlike those of other planets. If you took a closer look at the planets, you'd see most of them rotating in the same direction. There are two exceptions, Venus and Uranus. The reason for Uranus' tilt is still a big mystery. Most astronomers do not believe that the planet formed this way and was instead knocked on its side by an impact in its early history. The collision could have been with any object large enough to cause the tilt. The early solar system was comparatively crowded, and in such a system collisions were frequent. Most of these collisions would have been between small bodies, or of smaller bodies onto larger ones. Some of them would have been violent enough to cause changes to more massive objects. Scientists currently believe that both Venus and Uranus' odd spin properties were caused by two such collisions. The colliding objects must have been very massive and the collision violent to have caused changes to the two planets' direction of spin. Most of the solar system's planets, moons, and other objects bear the scars of early solar system bombardment. The most widely accepted argument for the formation of Earth's moon involves a collision with a very massive object early in the solar system's formation.